Computer. Hey, everybody. For today's class, we are going to be talking about factoring polynomials using the greatest common factor. Hold on, let me get this light fixed
We're
up.
not.
Let's just get this light fixed together. If you have any concerns, comments, or anything you want to say, please throw them in the chat while we do this recording real quick. Before you continue, please click like, share, and subscribe. I'm going to put the button right there. So it's going to say subscribe. I'm put it right there in that screen so you'll see it. Anyways. Anyways, we're talking about factoring. Yesterday we talked about simplifying polynomials, and I'm going to share with you what I'm talking about when we talk about factoring. Our learning section states that we are learning to perform operations with polynomials in order to understand nonlinear relationships between quantities. Our success criteria states that I will be successful when I can factor a polynomial using the greatest common factor. We talked about greatest common factor when we were in elementary school. You probably did it in kindergarten, probably first grade or second grade, but my point is it's some easy stuff, okay? So to continue, I'm going to go ahead and share my screen right here. I already have this quadratic equation thing expression right here. And if we're going to solve these, we're going to do distributive property, and we're going to go through and be bam. Oh, too short. Bam, bam, period. And we're going to do bam, bam. So we multiply each term on the left by each term on the right, period. So when we solve this, we're going to get something that looks like x squared plus 5x plus 6. Because we would have gotten 3x and 2x, and then you'd have to add 3x and 2x, which makes it 5x, and then you do 3 times 2, which makes it 6. So with this type of stuff, what we did just now was simplify. I'm going to try to write this the best I can. S-I-M-M-P-L-Y-F, simplify. Did you say M-M-P? That's on the board right now. If I don't know what I said. However, if I'm going from this angle to this right here, that right now is called factoring. See, it's the same thing. It's just the reverse, period. So I'm going to show you another example, all right, before we continue. Okay, so I'm going to show you another example. New thing. So if we have 2x, and then we have 6x squared plus 8y. And if we are trying to solve this, we finna use the distributive property. We're going to use the distributive property for all my other friends out there. So we finna use the distributive property. We go bam, bam, period. So we do 2x times 6x squared, which would give us 12x to the cubed, period. Plus 16xy, period. From the first part to that part, that is called simplifying. Simplifying is when you do the distributive property, you do the combining like terms, you do all the extra stuff. And from here to here is called factoring. So basically, if they had it written out like that, you have to find if they did it. That is a great question, okay? The question was, what if they gave us 12x to the cube plus 16xy, okay? And they would say factor this expression. we would do a thing that brings us to the top part. Period. Okay. Period. Now, we need to, you know, I talked about we're going to be factoring using the greatest common factor. The greatest common factor, period. In this case, I actually said period because I was putting period right there. And in this case, the greatest common factor is 2x, because 2x is in both of them. So our greatest common factor for this is 2x. I want you to also realize that, let me write this question back up here. 12x cubed plus 16xy. 12x cubed plus, you know what, this looks, no, I'm gonna write it over now. There it is. 12x cubed plus 16xy. We realize that 2x is a greatest common factor, right? We could get 2 and x from both of them, right? So that makes it a greatest common factor. So then if I'm writing that out, Mr. Midnight, I'm gonna use a different color, okay? 2x, comma, that would make it 2, so that'd be 6, because 2 times 6 would give me the 12. And then this would be x squared plus 8y, right? That right there would give me up here. But I could also get another greatest common factor from this. What's another one? How else can I? Actually, this one would actually be the greatest. This right here, 2x, is a factor. Please forgive me. This right here is the factor, but it's not necessarily the greatest common factor. 2x is a factor of it, but not a greatest factor. What else? What would be the greatest common factor for this? Greatest meaning something higher than 2. Ain't. It has to be able to go to both of them. Evenly. 4. So a greatest common factor for this one would be 4x, which would give me 3x squared plus 4y. So this is actually the GCF, the greatest common factor. So 2x is a factor, but it's not the greatest common factor. That could be a song right there, okay? 2x is the factor, but 4x not the... Yeah, that part. All right, so with all of these, you could find factors. So on a test or whatever you take, whatever it might be, it might say, hey, what are the factors of this expression? You're going to be able to get multiple factors from an expression. However, when it asks you, ooh, you see the pluralization right there? When it asks you for the greatest common factor, you're going to have to do the greatest one. So what if this right here, let's switch out. New question. What would be the greatest common factor for this question right here? Greatest common factor.
3.
Whenever we're solving these, we want to figure out what the greatest common factor is. It took us a minute, y'all. That's why I resumed the recording. Y'all probably wonder why how you jump from that part to this part, but it took us a minute to figure out what this greatest common factor is. So please forgive us. So 6x squared. Then you do your open parentheses, and you would get 2x plus y. Do you realize if you do the distributive property for this, it gives you back this? So we want to get out the greatest common factor, and then whatever is left, we put it in the parentheses. So we could have done 3x, but it's not the greatest. It's a factor, but it's not the greatest factor. We could have done 6x, but it's not the greatest because x squared could go into both. New question. Welcome back. This question says 8z y squared p to the 4th plus 3z squared yp squared. What would be the greatest common factor?
I'll say 2.5.
We're gonna resume the recording. I'm gonna tone down with my energy a little bit because, like I was saying, they are not picking up what I'm putting down. So we have to step back a little bit now. So we're gonna look at 8 and 3, and we're gonna see what is the greatest common factor between 8 and 3. Sorry. 8 and 3. What's the greatest common factor? What can go into both of these numbers without leaving a remainder? Yes, it's 1. In this case, I'm not gonna write 1 because 1 is 1. Like, why do I need to write 1? Now let's go to the next part. Z and z squared. What can go into both of these variables without leaving a remainder? What's common between both of them? Yes, just z. Now let's look at y squared and y. Let's look at p to the 4th and p squared. What can go into both of them?
2.
Period. P squared. And if you want, you know what? Let me go ahead and put the 1. Go ahead and put the 1, but we don't need to put the 1. And then since I've already been through all of my variables and all of my terms and everything, I'm going to put my open parentheses now. Now I'm going to put what's left. The 8 is left, because if I do 8 times 1, I'm going to get back this 8. What do I put a z next? No, because we already put it on the outside. Do I put a y or y squared? What do I put? I just put a y, because we already took one of them and put them on the outside. So we need another one on the inside. For the p, I'm just going to put p squared because we put 2 of them on the outside, so we got to put 2 on the inside to get the 4 up the top. I'm going to put the plus sign. I'm going to put 3 because we didn't put it outside, so we need something on the inside. Now, how many z's do I have left? Just a z, period. How many y's do I have left? None. We don't need the y. How many p's do I have left? So then I'm done. That right there is factoring. And
basically, I was right, but I just didn't.
Recording. Next question. What would be the greatest common factor for this one? Go ahead and factor it. If you're online, go ahead and factor it and send it over to me. Let me see it.